Welcome to this LCC Fusion Project presentation. In this session, we are grounding the Fusion system in hardware, specifically cards. Cards are the building blocks of the Fusion hardware. We will look at what a card is, why the node card is so important, and how function cards like the BOD card, the Turnout card, and the PWM card fit into the system.
We will also connect this to the four kinds of Fusion users: planners, builders, installers, and configurators. Each of them sees different benefits from the same set of cards.
Let us start with a simple question. When we say card in Fusion, what do we mean?
In Fusion, a card is a purpose-built circuit board with one main job. Some cards detect trains. Some cards move turnouts. Some cards drive signals or lights. Each card does its job, and they all talk together over the CAN bus. Physically, every card follows a common form factor so it can plug straight into the node bus hub with a standard connector. Each card has connections for 3.3 volts, 5 volts, and 12 volts of power, plus CAN bus, DCC, and two serial I2C buses, all coming in through that one edge connection. Instead of hand wiring 12 separate connections between every card, you drop the cards into the hub. This is similar to adding a video card to a desktop computer. Plug in the card, and you are done with the hardware upgrade.
So instead of one giant tangle of wires, we get a collection of focused building blocks that cooperate on the network, and they literally just plug into the hub. And when you outgrow a single hub, you can hang more hubs and cards off the same CAN bus, building little clusters of intelligence around the layout instead of one central box.
Exactly. You can think of it as replacing hardwired logic with LCC events and a handful of clean connections. That makes the layout easier to build, easier to expand, and easier to troubleshoot. It also means other modelers, or future you, can design new cards that follow the same mechanical and electrical pattern, plug them into the node bus hub, and they immediately become part of the Fusion ecosystem.
With that in mind, let us talk about the star of the show, the node card. In simple terms, what is it?
The node card is the local brain for a section of your layout. It uses an ESP32 to handle communication, run logic, and talk to other cards and devices over the CAN bus. It hosts the firmware, the configuration, and the logic for that area of the railroad. It listens for LCC events, makes decisions, and then either drives outputs or publishes new events back onto the CAN bus.
I like to picture it as a dispatcher sitting at that location, watching what is going on and deciding what needs to happen next.
That's a good mental model. And because you can have multiple node cards, you end up with a truly distributed system where intelligence is spread out across the layout instead of living in one central box. When running, no desktop or laptop computer is required because each node card has its own little computer with its own memory and storage. Multiple cards are connected together simply by plugging them into an LCC Fusion node bus hub.
And why did we choose the ESP32?
Because it's widely available, supported by the LCC open source software OpenMRN, costs only a few dollars, and provides excellent processing power, along with both wired CAN bus and wireless Bluetooth or Wi-Fi communications. It simply plugs into the node card and several other Fusion cards, giving us a powerful, inexpensive engine that the entire Fusion system is built around.
To make this more practical, it helps to think about four kinds of Fusion users. We have the planner, who designs the system; the builder, who assembles the hardware; the installer, who mounts it under the layout; and the configurator, who sets up events and logic.
The same node card and function card serve all four roles, but each role cares about slightly different things. So we will look at what each of them gains from this hardware approach.
Let us start with the planner. Why does the planner care about node cards and cards in general?
For the planner, cards let you put brains where the logic naturally lives. You design your layout in terms of blocks, districts, and scenes, and then drop a node card and I/O cards where it makes the most sense. That means shorter wire runs and more behavior expressed as events and logic instead of one-off wiring hacks.
So the planner thinks in scenes and blocks. Put a node there and let the cards handle the details.
Exactly.
How about the builder? What does the builder get out of this approach?
For the builder, cards turn a big, scary electronics job into a series of clear builds. You assemble one card, solder the parts, run the self-test, and then move on to the next. The bill of materials, the assembly drawings, and the test routines all support that. It feels more like following a recipe and less like guessing your way through a pile of parts.
For the builder, what about testing? Cards can get misbuilt pretty easily. How do we know a card is actually working before we install it?
Every Fusion card includes built-in self-testing. Before it ever goes on the layout, you can verify the power inputs/outputs, CAN communication, I2C communication, and the I/O pins, all using the node card's testing firmware or the serial monitor. The idea is simple. You test each card at the bench, confirm it's good, and then install it. It saves time, reduces wiring mistakes, and gives the builder confidence that the hardware is solid before anything else happens.
So once the builder has tested the card and everything checks out, what does the installer get out of this? How do they know the card is actually connected and behaving the way it should?
This is where Fusion really shines. When you plug a card into the node bus hub, the system automatically detects the card, reads its type, checks the communication bus, and verifies its address, almost like plugging a USB device into Windows and having it recognized instantly.
And that means the installer doesn't have to guess what's connected?
Exactly. But we go even further. Fusion includes specialized testing cards, one designed to monitor outputs and another designed to simulate inputs. You just plug these testing cards into the function card you're installing, and they instantly let you check, are the outputs doing what they should? Are the inputs being detected correctly? Is the card responding to events from the node? This makes installation incredibly fast and removes all the guesswork.
So instead of wiring up real turnouts and sensors during installation, I can just plug in a test card and try everything safely at the bench.
Exactly. And once everything checks out, you install the real devices, knowing the card and its configuration are already verified.
And then comes configuration, right?
Right. For the configurator, everything is structured. Each card announces what it supports, you load the CDI, assign your events and logic, and you're ready to go, with the confidence that the hardware underneath has already passed both auto detection and hands-on testing with the specialized test cards.
Okay, so let's talk about detecting trains on the layout. How does Fusion actually know when a block is occupied?
That's where the BOD card comes in, the block occupancy detector. Its whole job is to sense when a train draws current in a block. The moment something rolls in, the BOD card sees it and reports that state back to the node.
And that's just occupancy, right? What about shorts? Turnouts thrown the wrong way. Wheels bridging rails. All the fun stuff.
Right, and that's exactly why we built the BSD card, the block short detection card. Think of it as the BOD card's big brother. It detects occupancy and it watches for short circuits. If a short happens, the BSD card instantly isolates the block, protects the rest of the layout, and then automatically resets once the short is cleared.
So it's basically doing the job of those pricey DCC power district protectors?
Exactly. Right, it's really two boards in one. In addition to detecting occupancy in the block, it also handles short circuits, and it's completely configurable. You can set the current range that defines a short, and once a fault happens, the card responds automatically with no manual reset required. Both the BOD and BSD cards report their states directly to the node. And once the node hears from them, it publishes the appropriate LCC events out onto the CAN bus, where everything else, signals, logic, and automation, can react in real time. And here's a neat extra: the audio card can even play voice messages to operators, telling them exactly which block just shorted. So instead of hunting around the layout, you get clear, immediate feedback.
Alright, next up, turnouts. These always seem to be the part of the layout where everybody has a different motor, a different wiring scheme, and a different headache. So how does Fusion simplify all of that?
Fusion handles it with the Turnout card, and honestly, this is one of the most flexible cards in the entire system. The Turnout card works with multiple types of switch machines, stall motors, twin coil machines, servo-driven semaphores, even slow-motion motors, and it does that by using specialized breakout boards.
Meaning the turnout card stays the same, but the breakout board's adapted to whatever machine you're using?
Exactly. You plug the Turnout card into the node bus hub the same way you do with the other cards. Then you choose the breakout board that matches your switch machine, and that's where the specific wiring, power, and control circuitry gets handled. It keeps the planning simple because you're not selecting from different turnout control electronics. You're always using the same turnout card, and the breakout boards handle the differences.
So if someone has tortoises in one area, solenoids in another, and servos for semaphores elsewhere, they don't need 3 different control systems?
Right, one card supports all of them. And when we get to the breakout boards section later, we'll talk more about how those boards adapt the turnout card for each type of switch machine. And of course, the turnout card also manages frog polarity automatically using a relay, so you can place it near the turnout and keep the wiring clean.
Alright, so we've moved turnouts. Now what about all the other little things on the layout? LEDs, signals, crossing gates, even small motors. How does Fusion handle smooth control of those?
That's where the PWM card comes in, PWM meaning pulse width modulation. Instead of just turning things on or off, PWM lets us control the intensity or speed of a device by adjusting how long each pulse stays on.
So this is how you fade LEDs instead of just snapping them on. And how you get a motor to crawl instead of jerking to full speed.
Exactly. The PWM card gives you very fine control over lighting, effects, and small DC motors. Signals can fade realistically. Structure lighting can ramp up slowly. And motors, like for animation, conveyors, or accessories, run far more smoothly.
And I'm assuming, like the other cards, this all ties back into LCC events, right?
Right again. The node card receives events, for example, set signal to medium approach, and the PWM card generates exactly the right pulse pattern to make that happen. It's smooth, it's repeatable, and it puts all the electronics right where they belong, near the device, not back at a central panel.
Nice. So turnouts move smoothly, lights fade smoothly, and motors run smoothly, all without the installer needing to calculate resistors or build special circuits.
Exactly. The PWM card handles the electrical complexity so the builder and installer don't have to.
So up to this point, we've talked about cards, logic, and sensors. But we haven't really explained how Fusion actually reduces wiring. You keep saying events, but what does that mean on the layout?
A simple example is the button card. Let's say you have a push button on the fascia to throw a turnout. When you press that button, the button card doesn't send power or a control wire all the way out to the turnout. Instead, it generates an LCC event, basically a small message that says, "Button was pushed."
So the button isn't wired to the turnout at all?
Right, not even close. That event goes out over the CAN bus, and the node card, listening for that event, says, "Oh, that's a button for that turnout," and sends a command to the turnout card to move the turnout points.
And adding another button. That doesn't mean adding another long cable across the layout?
Exactly. Each unique event eliminates an entire wire run. Add a second button? That's just one short wire from the button to the button card. You don't run anything to the turnout, the event handles the communication.
That's a massive reduction in wiring compared to traditional layouts.
And here's the key idea: this is the power of the LCC architecture. Everything communicates through events, reducing wiring. LCC Fusion takes that architecture further by supporting more device types and by providing hardware designed to make all of this easy: specialized cards, simple breakout boards, consistent wiring, and a unified way to expand your layout.
So the combination of LCC plus Fusion's hardware design gives you flexibility, scalability, and no spaghetti wiring. Alright, so let's say someone is ready to try Fusion on their layout. Where do they actually start? It can feel like a lot of pieces.
It's easier than it looks. You always start with one node card, that's your local brain. Build it, power it, and make sure it passes its self-tests. Once that's running, you add just one function card, maybe a BOD card for block detection, or a turnout card, or a button card for inputs.
So the idea is, don't build the whole system at once.
Exactly. Fusion works best when you grow it step by step. Node card first. Add one card. Verify the events. Make sure everything works as expected. You're basically building a tiny LCC island, and once it's working, you expand it.
And then when you're ready to connect more cards,
That's when you plug everything into the node bus hub. The hub lets you add multiple cards cleanly: power, CAN, I2C, everything goes through one connector. And the nice part is, each time you add a card, the node automatically detects it, validates it, and starts listening for its events.
so it's really just build one card, test, add the next, test again, and the system grows with you.
Exactly. Fusion scales one card at a time, no jump in the deep end moment. And because events tie everything together, each new piece feels like it just snaps into place.
Alright, so if someone is just getting started, what are the most common mistakes people make? What should they watch out for?
The biggest one is trying to build everything at once. People get excited, print 5 cards, solder them all, plug them all into the hub. And then nothing works because they skip testing each one as they went.
So we're talking about the kid in a candy store problem, building the whole system before checking if anything works.
Exactly. Fusion is designed to grow one card at a time. Build the node card, run the self-test. Add one more card, confirm the events. It's simple, it's fast, and it avoids the classic "where do I even start debugging this?"
Makes sense. What about documenting IDs and roles? I know LCC uses a lot of event IDs.
Right, another common pitfall is not documenting event IDs, card addresses, or what each card is supposed to do. It's easy when you have 2 cards. But once you have 6 or 10, knowing which event controls which device becomes essential. The best practice is simple: write down the card type, its address, and the events it produces or consumes. Fusion's configuration tools make this painless, but you still want to reference as your system grows.
So really it comes down to 3 things: build slowly, test as you go, and keep good notes.
Exactly. If you do those 3 things, Fusion stays smooth, predictable, and incredibly easy to expand. And remember, events keep everything modular, so good organization makes it even more powerful.
So by this point, we've talked about node cards, BOD cards, turnout cards, PWM cards. And there are even more cards in the Fusion ecosystem. Can you give us the big picture view?
Sure, Fusion is built around the idea of purpose-built cards. Each card does one main job and does it well. You've got cards for detecting trains, cards for moving turnouts, cards for controlling lighting, cards for reading buttons and sensors. And they all plug into the node bus hub the same way.
So instead of one giant universal board trying to do everything, Fusion breaks the layout into small, specialized modules.
Exactly. That's what gives Fusion its strength. You mix and match the cards you need for your layout. If you have 16 turnouts, use 2 turnout cards. If you have 16 blocks to detect, use 2 BOD or 4 BSD cards. If you're going heavy on lighting, drop in a couple PWM cards. Each card is independent, simple, and well-defined.
Almost like building with Lego bricks, each piece has its purpose, and the node ties them all together. Pause.
Exactly right. Fusion cards give you the building blocks, and the LCC event model makes them all work together seamlessly. And the best part? Because everything is modular, your layout grows naturally, one card at a time. Pause.
And later on, we'll talk about how the breakout boards expand each card to support different devices. Pause.
Right. The cards give you the brains and the muscle, and the breakout boards give you the flexibility to adapt them to just about anything on your layout. Pause.
And in future episodes, we'll dive deeper into each specific Fusion card so modelers can understand what they do, how they install, and when to use them. Alright, before we wrap this up, let's hit the big takeaways from what we've talked about today. There's a lot of information here, but the core ideas are actually pretty simple.
First, the node card really is the local brain for each area of your layout. It handles logic, listens for events, and connects everything together through the CAN bus.
And all the Fusion cards, BOD, BSD, Turnout, PWM, button, those are like the senses and muscles, each with one clear purpose.
Exactly. Each card does one job well, which keeps everything modular and easy to understand.
Another big one for me, using LCC events instead of wiring. No more running wires from every button to every turnout.
Right, each event replaces an entire wire run. Press a button event node command to the correct card. Simple, clean, reliable.
And Fusion grows naturally. You build one node, add one card, test it, and expand from there.
Exactly. Start small, test often, and let the system grow with your layout.
And those breakout boards? Those are what make the cards work with different motors, sensors, and devices.
Right. Cards give you the core function, and breakout boards adapt them to the real-world hardware you're actually using.
So the combination of the LCC architecture and the Fusion hardware design gives you a system that's powerful, simple, and expandable, one event, one card, and one node at a time. Stay tuned, we've got a lot more Fusion topics coming up in future episodes.